Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use TIA Portal version 17 and how to use the scale with the PLC S7-300. In this section, I will use analog input module SM331 7K F020A to test with the scale. And the objective of this lesson, we can convert from the analog input to show the actual of the raw value. Example, the actual of temperature, the actual of pressure, the actual of current of motor, or something. We can scale it. Okay. And before go to create the new project of TIA Portal version 17, I would like to explain the concept and how to wiring and how to selection the setting of this analog input. Because we have many options that we can use. Example, if we would like to use the connection with the current, example 4 to 20 milliamp, 0 to 20 milliamp, or volt 0 to 10 volt something, or we can connect with the PT100, RTD, or TC, yes, thermocouple. We can also use this analog input. Okay, so this module have many functions that we can select to use. So we need to know about the concept. Okay, so first let's go to concept. I will explain a little bit about how to wiring and how to selection the object. Okay, so let's go. So here is the analog input module that I already installed in the rack of PLC S7-300 CPU 314C2PN/DP. Actually, if we purchase this CPU, we will got the analog module, 5 channels, and analog output, 2 channels, and digital input 24 bit, digital output 16 bit. Okay, so in the previous video we already learned about this module, but in this section I just add more module, this module. Yes, so in this module it is the special module that we can select with the option. There are 4 options that we can use. If we select send to A, let's see A, it means that we can use millivolt or PT100. Yes, and if we select to B, we can use volt input 2.5, yes, 5 volt, 1 to 5 volt, or 0 to 10 volt. Yes, so in the option of TIA Portal, I will focus about how to select it. Okay, so this hardware we can take out by using the screwdriver. We can take out it and then selection it. Yes, so if we select this option to C, it means that we use 4 wire current. Yes, 4 to 20 milliamp. And if we select to D, we can use with the 2 wire current. Okay, so if we would like to supply to the transmitter, we can use select with 2 wire and then we can use it. Okay, So this is very important. If we select wrong selection and configure the software, it means that the hardware and software configuration must be the same. Example, if we select this one to A, so we can config on TIA Portal, select to A also, and then use with the PT100 or TC. Okay, so I hope everyone got this point, very important. And we need to know about how to wiring also, okay, before we can use this module. So I will detail also. So here is the three part or three option that I already draw about this module. Yes. So example, this module use with current or volt. So we can use like this. And the address will start from PIW 206, 256. So there are totally 8 channels. Yes. So it will start from PIW 256, 258, 260, 262, 264, 266, 268, and the last one is 270. Okay. So this is the option 1 if we would like to use current or volt. So if we would like to use with the PT100 or RTD or thermocouple, yes, we can wiring follow this step. So we need to jumping the terminal number 2 to terminal number 4, and then terminal number 3 and terminal number 5 together. If we would like to connect directly from PT100, and the address will start from PIW 256 also. Actually, this address everyone can change by manual when make the hardware configuration. Okay, so this is the default of the address. Okay, and here is the option number 2. So if we select with the TC thermocouple, we can connect like this. Use only 2 terminal. Yes, and the address is not the same. Yes, it doesn't the same with the volt and current. Let's see PIW 256 for channel number 1, PIW 260, right? And it will jump to PIW 264 and jump to PIW 268. Okay, so totally we can use only 4 channel if we select with the PT100 or TC. Okay, and for the option number 3, this just combined with the option number 4, option number 2. So if we would like to connect with the PT100, we can use only 4 channel. Okay, and the connection is similar to be option number 2. Okay, so this is very important because it is the basic of wiring. If we don't know about how to wiring, we cannot use this module. Okay, so I will go to next step about how to create the new project and then test with the real PLC hardware. Okay, so I hope everyone got this point. Yeah, it is the basic. Okay, so let's go to create the new project and then we can test with the scale. Yes, because right now I already connect the standard source, RTD calibrator, and source current through the module. Yes. So I will focus when we create the new project. So let's go. Okay, so here is the software TIA Portal version 17 that I already installed in my PC. So first we can go to create the new folder. PLC S7-300 Analog or scale tutorial. Okay, and then let's open the TIA Portal version 17. We will create the new project and we will go step by step together slowly. Yes, for easy to understand. Then we can go to create the new project. Yes, I will put the project. TIA Portal scale. And then browse the folder that we already created on desktop. Okay, PLC S7-300 scale tutorial. And then let's click create to create the new project. And in this section we can create the HMI to show the actual value on the HMI also when we select from the analog input. Yes. Okay, so let's go to project view. And we need to add the new device, right? So to add the new device, let's go click new, add new device, double click. And then go to controllers. And then choose schematic S7-300. And then choose the CPU 314C 2PN/DP here. Right now version 3.3. Yes. Okay. So wait a moment for create the hardware configuration. Okay, good. So here is the PLC module and rack, yeah, automatically created when we choose this CPU. And I will add new device for HMI, yes, because we use HMI also. I will choose 7-inch TP700 Comfort. So take time a little bit more to create the HMI device. Okay, then we can go to connect with the PLC. Yes, PLC 1 here. And click finish. So we need to add the HMI first. Okay, And then we can go to check the device network. Make sure the HMI and PLC was connected. Yeah, and we can view the IP address. So the IP address of PLC is 192.168.0.1 and HMI is 192.168.0.2. Yes, so that's good. Or we can check here connection. We will find the HMI and PLC was connected. Yes. Okay, next let's go to our hardware configuration. Yes. And then we can go to the CPU. Yeah, this is a CPU 314C 2PN/DP. So next step we need to add the analog device, right? Here, this one. So SM300 7KF02. Yes. So we can go to the AI and then 12-bit, right? So this one 12-bit. Okay, let's see. 331 7KF02. Okay, so click it and then drag and drop to the rail. Okay, and then let's see the address will show here. IW256. Yes, start from IW256 and then earn IW270. Okay, so that's good. And then we need to download the hardware configuration to the PLC. So I will save the project and then I will compile the project first. Okay, there is no error. And then I will connect LAN cable from the PLC to my PC. So let's go to check. Make sure the LAN cable connect. Okay, this one. I will connect the LAN cable now. Okay. The LAN cable was connected. And then we can go to the PLC one and then we can download the hardware configuration by press this button, download to device. So we need to select the correct network adapter. Yeah. So now I will select Intel. Yes, my network card. And then we can start search. This one, we need to select this one. Okay, now it detect one CPU 314C 2PN/DP and here's the IP address and here's the target name. Let's see target name PLC_1. Yes, and this is a CPU device type. So we can click load to download the hardware configuration to the CPU, right? But before download, let's go to check the hardware configuration because we need to select with the correct selection. Yes, as I explained here, we need to check. So the channel number 0 I would like to use with the current for Y, so I may select to C. Yes, so we can go here, go to property, yes, make sure the selection was selected correctly. So let's go to channel number 0. I would like to use current, right? Okay, I will go slowly because this is very important. So if we property of this module and then go to tab general, we will see the 8 channel of analog input, right? Right now, channel number 1 or channel number 0, I will use current for Y. So I will select to current for Y transducer. Yes. And then I will use 4 to 20 milliamp. Yes. And for channel number 2 and number 3, I also use current for Y for 220 milliamp also. But for channel number 4 and number 5, I will use RTD. Yes. So I can select RT thermal resistance linear, and I will choose the standard PT100 standard range. Okay. And for channel number 6 and number 7, I also use RTD. Yes, and select to PT100 standard range also. Okay. And if we need to use the some analog of the built-in module, we can also go to property. Yes, we can change only one time and then download it. Okay, so we need to know about this one. If we would like to select any option, we can select. Yeah. Right now for the analog built-in the CPU, I will input, I will go to default, but analog output I will set to current for 220 milliamp also. Yes, because if we would like to use with control the some electrical devices, example actuator or damper or dry, yes, we can also configure it. So basically the channel number 0 of analog output, I will use 4 to 20 milliamp. Yes. And for channel number 1, I will use volt 0 to 10 volt. Yes. Okay, good. So we can save the project and then compile again before download. And then we can download. Okay, select the adapter again. Search again. This one, direct 82, maybe I can select this one. Okay, it detects one PLC, and then we can click load to download the hardware configuration to the PLC. And during load the project, we will stop the PLC. Let me show the status. Let's see, right now the CPU was running, so I will click load and CPU will stop. Okay, and when finished I will restart the CPU and CPU was running. And then we can go to create the scale. Yes. So basically, in the channel number 0, I will use current source, right? So let's go to our program blocks. Go to main OB1. So this one, use scale to convert the actual current of motor. Yes. So example, the current of motor, we would like to use the analog to show the actual of current, right? So we can use scale, and we have two ways to find the scale. The first one, we can select here and we can type scale. Yes, we will go like this, or we have to find. If we can find this one, we can go to instruction. Yes, go to tab basic instruction and then go to conversion operation here, and then we can find the scale. Yes, scale here. We can drag and drop the scale to use. Okay, so I will drag and drop the scale to use. So in this section I will integrate between scale and unscale. Yes, scale is used for convert analog input, and unscale used for convert analog output. Okay, we will go to unscale also, but we need to learn about the scale first. Okay, so example motor current start from 0 to 280 m. Yes. So how to scale it? So first we need to know about the high limit of the current motor, right? So high limit is 280 m. So I can put here 280.0 because it is the real. Yes. We can push F1 to see the hell. Yes. Wait a moment, I will show the hell. So if we would like to use another instruction, we can read the hell from the content. So there are many methods. Yes, and we can read it. So let's see, here is scale. Yeah, it is the description and is the meaning of scale. Let's see, here is the formula of scale, and here is the raw value, maximum value. Yes, so here is the detail of block. We have input, high limit, low limit, and bipolars. Yes, and you can read it. And here is the scale. Let's see here. Take input value, high limit, take low limit, and this is the output value, and here is the error. Okay. so we can read it later. So right now we will use the one analog input start from the channel number 1, right? So we can go back the channel number 1 a little bit. So it will start from IW256. Okay, so here I will put IW, or we can type PIW256. Yes. Example, analog current. Yes, we can rename the tag, and we can type analog current motor. Analog current motor. Yes. And here is the high scale or high limit of current motor, 208 GM, and here is the low limit, so I will start from 0.0, and this one is the bipolar, so I can put another address, example M0.0, and here is the value, right? So basically I can type current CURRET val. Yes, and here is the actual current of motor that we would like to show. Example, show on SCADA, show on HMI, so we can define it. Okay, so I will put motor 1 current, and then we can define the tag by right click on the network and then define tag. So there are two tags that we would like to define it. So I will use the global memory, this one global memory also. Yes. Okay, so that's all for scale, and then we can save and then compile the program, and we can test. Okay, we can download. I will download to device, and we can online. Okay, we can online to check the status. So let's see, here is 0M, right? Because I select the standard loop source current to 4 milliamp. Yes, the value swing a little bit. Let's see here, -8 to -24. Yes, so we will go to select the current loop, and then let's see this value together. Okay, so right now the position of current loop is 4 milliamp. So if I adjust to 8 milliamp, let's see the value is increased. Adjust to 12 milliamp, increase. Adjust to 16, increase also. And if I adjust to 20 milliamp, it also increase. Okay. So it increased to the maximum. Let's see here, 280 m. Yes. So we need to show this one to the HMI, right? So basically we can go to HMI, our HMI here, root screen, and then we can use the rectangle, yes, and then we need to use the IO field to show. Okay, like this, and I will put the label current motor. I will change the background of screen and then change this color to be yellow. Yeah. So current motor is show like this. I will go to the text layout and then uncheck this one. Then we can adjust the size. Okay. So this one we can adjust. Go to apparent. I will adjust the background to be black, and text I will adjust to green, and this one I will adjust to solid and choose the white color. Okay, adjust this one to 1. And if we would like to know the value of this IO field, we can go to general and then choose the text that we already created here. Yes, we already defined the text. So motor current here, and then it is the output, right? And for the format pattern I will use 999.99. okay, and then I will go to the text format and then center, and for the unit it should be M, right? Okay, I will change the text apparent to be yellow. Okay, and then we can simulation. Yes. Okay, right now it's so I will adjust this one a little bit. No good, right? Okay, like this, and then we can simulation again. Okay, so right now it's so around 280 m. Yes. So if I adjust the standard source, I will adjust it, and let's see together. Okay, I will adjust to 16 milliamp. Let's see around 200 m, right? 12, 8, and 4. 4 is 0 m. 8, 12, yes. Okay, so we can show it on the HMI. And next step we will use the UNSCALE, right? So how to use UNSCALE? Oh, one more, I would like to show the temperature of the motor also, right? Because we already select it on the hardware here. So let's go to create the temperature of the motor first, because I use the RTD calibrator to example. Yes. Okay, I will offline first. And for the analog signal with the PT100, we cannot use the scale formula. Yes. So we need to convert from the raw value, convert from integer. Yeah, this one actually this one is integer. Let's see here, the data type is integer, so we need to convert to real, right? Okay, so how to do it? So this one I need to show the current, sorry, show the temperature show the actual temperature of motor on HMI. Yes. So basically we can go to convert, right? So we can go here and we can type conv, it means that convert, and then we need to convert from integer to double integer, right? Because PIW, yes, 264, right? It is the integer. So here I need to convert from integer to double integer, okay? Because we cannot convert directly from integer to real, and then we can convert step by step. Yes. So here is the address, this one, right? IW264. It is my sensor that connect to this analog input. So here we can type PIW264, and then we can rename the text as temperature or molar temperature. Okay, change. And then for convert, we can use the temporary variables. Okay, I will zoom out a little bit. So we can use the temporary variable by add new, add row, yes, or insert row. Basically, we can insert another row that we want, yes. So here example temporary one. Let's see here, I need to convert from double integer to real, right? So I will put like this first for easy to understand. So convert from integer, from double integer to real, right? Okay, and then I will divide real. So divide real, and this is the result, right? Result that we would like to show on the HMI. So example molar 1 temperature, molar 1 temp, yes. So I need to create the temporary variable with the double integer at that time, right? So example temp1, and the data type should be double integer, and we can drag and drop to use here. This one also, and then I will create one more variable with the real data type, right? So example temp2, this should be real. Okay, and then we can drag and drop to use here. And here also we can use temp2 divided by 10.0, right? It is the formula. So this one, drag and drop the temp2 here, and then I will define the text that we would like to show on the HMI. So I will use global memory. So the %mdh, yes. So that's all for convert with the temperature. So let's see here. It is different between how to use the scale and convert with the PT100, right? Okay, I will compile the program. There is no error and warning. Then we can download. And we can online to see the status. Okay, right now temperature around 0 degrees Celsius, because I put the clip of the RTD calibrator to 0 degrees Celsius. So let's test. Okay, right now I will push the clip of the RTD calibrator to 50 degrees Celsius, 25 degrees Celsius, sorry, 50 degrees Celsius. Yeah, let's see here. 50 degrees Celsius, around 54, right? 100. Okay, and this one 150. Yes, so it error a little bit. Okay, so it worked perfectly, and then we can show the result to the HMI, right? So we can go to root screen, and then we can copy this one. Yes, copy and paste. And this one should be temperature of motor, right? Motor temperature, motor current. Okay. And this one should be degrees Celsius, right? Okay, degrees Celsius. And we need to go to the general, right? To put the text, go to general, and then we can browse the text from the program blocks, PLC text, and then it is the motor temperature, right? Okay, and this is output also. And then we can save and then simulation to see the actual. Okay, right now it's so around 53.6 degrees Celsius. Oh, I need to adjust this one a little bit. This one, right? So I will go to and check the fit object. This one also. Okay, and then we can adjust it. Okay, like this. Okay, good. So here we can put the parameter motor 1 status. I will increase the font size to be bigger than. Okay, so if I adjust or insert the motor, okay, let's go to motor. And then I will insert one motor here. I will change to this color. Yes. So we have current, temperature, and set speed, right? And we had start and stop. Yeah, we have start and stop also. We will create the example logic to start and stop the motor. So start button. Okay, start button. I will change to color blue color for start. Text color should be black. And I will increase the size to be 21. And I will copy for stop button. So this one should be stop, right? And then I will change to red color. Okay, good. And then I will make the alignment. Okay. We have start and stop, and we have the status, right? When run and stop also. So we can change this one to be red color. Okay. And then we have one more for set point of speed, right? Example, set the frequency. So I will put like this. Okay, we can adjust a little bit more. Okay, like this. And then we have one more for set point speed, right? Okay. So I will copy and paste, because we need to use the UNSCALE to set point the speed, right? Okay, I will adjust this one a little bit like this. This one I will change to motor 1 controller. And change this color to be white color. Okay. I will adjust to be 25. Okay. And this one should be set point, set frequency, right? C, yes. So this one should be hertz, right? Frequency is hertz. The unit is hertz. So I can align to be like this. So we need to create the UNSCALE and start and stop the motor also, right? So come back to our main OB1 and then I will outline first. So I will create start and stop command to motor from HMI. Yes. So basically I have stop button, start button, and then output, right? And then I will hold the signal also. Yes, hold the signal also. So example, I have stop motor. This one start motor, and this one motor 1 dry, and hold the signal by motor 1 dry. Yes, and then we can define text. I will use global memory for start button and stop button, and for the output I will use global output. Yes, and the output we can go to check here, hardware configuration. Okay, I will cancel first. We can check the hardware configuration here. Yes, so let's go to output. Okay, so the output will start from Q136.0, right? It is the built-in I/O built-in CPU. So we can define take this one global memory, this one global memory, and this one output, global output, and start from %Q 136.0, right? Okay, and then click define. Yes, and we need to set point the frequency of motor, right? Okay, so we can go to UNSCALE. We will use UNSCALE. So this one we can command set point frequency of motor to VFD from HMI. Okay, and then we can go to use the UNSCALE, right? So go to the instruction here. Yes, basic instruction, and then we can go to UNSCALE, drag and drop the UNSCALE to the network. We will go like this, and we can push F1 to read also. It is the UNSCALE, and we can read the formula. Yes, and read the instruction here. Okay, so here is the set value from the HMI. So I can put set value speed, and then I can use the maximum 0 to 50 Hertz. Yes, my motor 0 to 50 Hz. So here I can put 50.0, start from 0.0, and here is the bipolar. So example set BP, yes, and this one the frequency, right? Frequency out. So sorry, it is the return value of frequency. So we can write frequency underscore ret underscore value, and here is the actual, the set actual frequency, yes, and then we can define text. So here I can define as global memory, this one global memory, this one also global memory, this one global memory. Okay, sorry, this one I need to change a little bit because we need to use the analog output, right? So I will change to use the analog output. So analog output, it will start from, okay, let's go to hardware configuration here. Analog output is QW800, right? So I will use channel number 1. So let's go to define text again. Frequency to VFD. Okay. And then I can define text again by using the output, yes, and then it is the word, right? QW800, yes, and then we can save the project and then compile, no error, and then we can download. Okay, and then we can online, and then we can modify this value, example 25 Hertz, yeah, and the milliamp will increase, yes, I will show. But right now let's go to add the screen first, yeah. So here we can go to the property, go to general, and then browse the text that we already created here, yes, frequency to VFD, sorry, set value, right? Frequency set value, right? Okay, set value speed here, and it is the input output, right? Okay, So I will use the format 99.99. Yes, because we have only 50 Hertz, right? And then we need to create the start and stop the motor also. So I can go to start and stop right here. Can go to events. Freeze, I will set bit. And then we can browse the text that we already defined here. Stop motor. Sorry, start motor. Because it is push button start, right? Okay. And if I release, I will reset bit. Start also. And for stop, when I press, I will set bit. So I will set bit stop. And when I release the button, I will reset bit. Set bit stop also. Yes. And for the status, I will go to animation. Go to display, add new animation, and go to apparent. And then change this one to be motor 1 dry. And when it on, I will change to green. Yes. So that's all. And then we can test it. Okay. We can simulation. Okay, we can go to OB1. And then we can start the motor. Yeah, let's see. The motor is running. And the output is turned on also. And then we can set the speed. Example, we use the set speed here. I set 28 Hertz. And I will show the status of milliamp on the multimeter. Yes. Okay, so we can set speed. Yeah, example, I set 25 Hertz. Yes, it should be 12 milliamp, right? So let's see the milliamp show around 12. Yes. So I will adjust to be 45 Hertz. Milliamp around 18. I adjust to 50 Hertz. Okay, 20 milliamp. If I set to 0, it will fall, right? I set to 36, 15, yes. So that's correct. And for current the motor and RTD, we can also adjust. Yes. Current adjust to maximum. Temperature around 100 degrees Celsius, right? Okay, that's correct. So this is just example about how to use the TIA Portal version 17 to create the project and then link with the PLC S7300 by using the scale, yes, and unscale. So I hope everyone will get this point, and I hope everyone can do it, yes, because I already go slowly, step by step, right? So thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.